Okay, in this diagram, we have a totally generic right triangle. All right, it's got a 90-degree angle, but we don't know anything else about it. We're going to go ahead and say that this angle here is A degrees. Okay, I don't know how much it is, so we're going to give it a letter. Now, I think at this point, we can all agree that if I made another right triangle that also had A degrees on one of its two angles, that those two triangles would be similar. So any proportions that we find will work for any right triangle with this A degree angle. Okay? Now, we don't know what they are, obviously, because we don't have any numbers. But these ratios are so commonly used and so useful that we gave them names. I'm going to call this angle B degrees. And we're going to say that the side opposite from angle A, we're going to call this the opposite leg. In this particular diagram, yes, it's shorter than the other leg, but it won't always be that way. So we're going to call this the opposite leg because it is opposite A degrees. Okay? And then we're going to call this side here across from angle B, we're going to call this the adjacent leg. Adjacent means next to, so it's the leg that's next to our angle A degrees. And of course, the hypotenuse is the hypotenuse. Now again, because we're working with a generic right triangle, we don't know what any of these numbers are. But we do know that whatever it is, the opposite leg divided by the hypotenuse is always going to be the same. This multiplier between the hypotenuse and the opposite leg will be the same for every single right triangle that also has this A degrees. Again, because of similarity. And that is so incredibly useful that we gave it a name and we called it sine. Sine of A degrees, you have to note this angle because, of course, if we were looking at angle B, then suddenly this is opposite and this is adjacent, right? From angle B, the opposite and the adjacent switch places, but the hypotenuse, of course, stays the hypotenuse. This, by the way, is actually spelled sine. It's not a sin. There's nothing evil about it. And we will be able to find this using a calculator. Okay, so that's just one pair, though. That's just one ratio. That's the opposite leg divided by the hypotenuse. We've got other pairs that we can work on. We've got other ratios. What if we took what about taking the adjacent leg and finding the ratio between that and the hypotenuse? Well, we have another name for that. So again, cosine of A degrees, this is pronounced cosine. All cosine means is the length of the adjacent leg, in this case this one, divided by the length of the hypotenuse. We're just giving a name to this relationship, to this ratio. Finally, there's really only one pair that we haven't done, right? We could do hypotenuse over opposite, but that's just the reciprocal, right? We'd just be flipping the fraction over. The last one is we can take the opposite leg and divide it by the adjacent leg. And we call that tangent. And with this information right here, you will very soon be able to have complete mastery over all right triangles. All you'll need is one angle and one side, and you'll be able to figure out everything else using the Pythagorean theorem, and then using these three ratios: sine, cosine, and tangent. And again, I want to try to make this as clear as possible. Sine is just a special name that we gave to the ratio of the opposite side from that angle divided by the hypotenuse. It's just a special name that we gave to that ratio so that when you pick up your calculator, you can look at a button and see, oh look, that says sine. Now, it used to be way, way back before calculators could do these. If you wanted to know what, for example, the sine of 42 degrees is, for example, if you wanted to know what the sine of 42 degrees was, you would have to open up a book and page through pages and pages and pages of tables where you would just look up 42 degrees, you would look up the sine column, and it would tell you to about 5 or 6 decimal points what that ratio is. Thankfully, we have a calculator. Now, I'm going to show you on Google's calculator how to input this, but for now, I'm going to use my own calculator, and I'm going to say sine of 42 degrees equals 0.669. Nice. And that's just a calculator thing. So to put this into perspective, just so we can be clear, when you are working with right triangles, you no longer have to have two triangles to compare. You no longer have to have a bigger and a smaller triangle to multiply. You can use sine, cosine, and tangent to find all three of these sides, along with the Pythagorean theorem, without having to have a second triangle to compare it to. Now, how do you remember this? I'm going to share with you a mnemonic device that my teacher taught me and his teacher taught him and blah, blah, blah. We call it SOHCAHTOA. SOHCAHTOA. In other words, sine is opposite over hypotenuse. Cosine is adjacent. Note that I'm only writing ADJ for adjacent and HYP for hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA. Sine is the opposite over the hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over the adjacent. Now, one thing really fast. You can't just say sine. Okay? Sine is not a thing. It's not a number. It's not a variable. It's not a thing that you're multiplying by. It is like multiplication. Sine is a mathematical process. So you have to say sine of a degrees. And that's super important because, again, if we look at this triangle again, but we look at it from the perspective of angle B, well, now this is the opposite leg, right? Because it's opposite the angle we're talking about. And this becomes the adjacent leg. So when you talk about sine, cosine, and tangent, it has to be sine of something, of some angle, cosine of some angle, tangent of some angle. Again, it is an operation, not a number, not a variable. You're never going to divide both sides by sine. Sine isn't a number to multiply or divide by. So now we're going to take a look at the calculator, and we will see if I can help you figure out how to do this. Okay, so here's a picture of the Google calculator that you can find just by typing the word calculator into Google. You will notice that it has sine, cosine, and tangent. They're right there. Now, for the Google calculator and for my calculator, you hit sine first, and then you hit the number. When we did sine of 42, we did sine 42, right? But there are a lot of calculators out there where you have to do it the other way. The iPhone calculator is specifically like this. For the iPhone calculator, you have to put in 42 first, and then you hit the sine button. You have to do it backwards. You put in the number first, and then you hit the sine button, and it'll give you the answer. So, a quick recap. If I have a right triangle, and this angle here is A degrees, then we define sine of A degrees to equal the length of the opposite side, that's this one, divided by the length of the hypotenuse, that's this one. That is the SO in SOHCAHTOA. Sine is opposite over hypotenuse. And we can find that ratio really quick using a calculator. Similarly, just the same, cosine of A degrees we define as the adjacent side divided by the hypotenuse. That's the adjacent side, the one that's next to the A degree angle, and the hypotenuse. And that's where the ka in SOHCAHTOA comes from. Cosine is adjacent over hypotenuse. And finally, the very last one, tangent of A degrees is the opposite leg over the adjacent leg. That's the TOA. Tangent is opposite over adjacent, TOA. Now again, for now, this only works for right triangles. We will find a way later on in the year to apply this rule to all triangles, but for now, we are focused just on right triangles. But I want to make this known to you. We are not just talking about a right triangle here. These tools, sine, cosine, tangent, plus the Pythagorean theorem, give us the ability to find the sides of any right triangle in the universe. And in the next video, we're going to do just so many examples of using sine, cosine, tangent, the Pythagorean theorem, and those two special right triangles that I mentioned last time, or that I went over last time. We're going to use all of that information to solve just a bunch of problems, okay? So the next video that I release will be a whole lot of examples on how to do this stuff. For now, you're going to want to take a look at the two topics, trigonometric ratios in right triangles, which will just be asking you to identify them. Which two of these over each other is sine, which is cosine, and which is tangent. And then secondly, the second topic is solve for a side in right triangles, which is using this ratio, once you know it, to find actual side lengths. Once again, make sure you're watching the videos on those topics and looking through the hints and reading any articles there are if you are confused. There is lots and lots and lots of support out there for sine, cosine, and tangent. There are hundreds and thousands of video tutorials out there. There are articles, there are books, there is a lot of information out there. So, if you're having a hard time, see what you can find, or email me, please. I would love to be able to address your questions, but I can't do that if I don't have any questions to answer.